Today we're just going to learn a little introduction to acids and bases. So we'll talk about some properties of acids and bases. Then we'll talk about how do we measure pH for acids and bases. So acids and bases, they're everyday substances that we encounter in our lives, both inside like chemistry labs, but also just in your everyday life. So we're going to start with just some properties. So go ahead and write down the properties of acids. Okay. So acids produce hydrogen ions in water. And go ahead and get down the H plus in your notes. Most of the time, instead of saying hydrogen ion, you're just going to see it as H plus. They taste sour. They corrode metals. They'll cause indicators to change colors. We're going to circle back to indicators at the end and like before our lab, because today we'll look at different indicators changing colors. And then acids can be weak or strong, okay? So they're not all the same. And we're primarily going to use the Arrhenius definition of acids, where we look at the hydrogen ion concentration. So the more hydrogen ions that are present, the stronger the acid is. Then the less hydrogen ions present will be the weaker the acid is. All right, next we'll look at bases and properties of bases. So bases produce hydroxide ions in water. Make sure you get this OH minus in your notes. Okay, so that's what a hydroxide ion is. Okay. These taste bitter. They feel slippery. Like think cleaning supplies. Okay, so most of your cleaning supplies are bases, and if you've ever touched them, do something they kind of feel like soapy or slimy a little bit. Okay. And once again, bases can be weak or strong. Okay, so depending on how many OH ions are present will determine how weak or strong that base is. All right, next we're going to look at, well, how do we name acids? You do not need to write this part down. Okay, I just want you to pay attention for these next 3 slides. Okay, I want to show you how we name acids. However, we're not going to spend time this class on learning how to name acids. There's not like a test question on them. But I just want to show you like in general, how do we name them? Okay, so acids have an H for hydrogen. And then the X is either, it's whatever is bonded to that hydrogen. So it can either be a monoatomic ion or a polyatomic ion. Since our acids all have a hydrogen in them, we focus on whatever the second part is when it comes to naming. So there's kind of 2 options in how we name acids. The first one is if it's a monoatomic ion, so just 2 elements bonded together. The first one's hydrogen, so it's always hydro. And then whatever that second element is, we take the stem of the name of the element and add ic to it. So for example, HCl is just 2 elements. So it's just hydrochloric for chlorine and then just ic. Okay, so hydrochloric acid. Okay. HBr would be hydrobromic. Okay. HF is hydrofluoric. The other option is if hydrogen's bonded to a polyatomic ion, we look at the name of that polyatomic ion. Okay. So do you remember all your polyatomic ions just on your naming chart on the back of the periodic table? Okay. So we just look at the polyatomic name. If it ends in 8, then it just becomes the stem of the polyatomic and an ic at the end. So for example, hydrogen is bonded to NO3, which is nitrate. So we just call this nitric acid. If the polyatomic ion ends in ite, we still take the stem of the polyatomic ion, but instead it ends in us. So if it's hydrogen bonded to nitrite, it just becomes nitrous acid. So we don't have to know those. I'm not going to make you name acids in here. There's no test question on naming acids. I just want you to see like, well, what's the difference between like sulfuric versus sulfurous acid? Okay. And then finally, bases are super easy to name. So bases are ionic compounds, and the name of the base is just the normal name of the ionic compound. Okay, so for example, what's Na? Sodium. What's OH? So close. Hydroxide. Okay, so you just put them together. Sodium hydroxide. Later today, we're going to work with calcium hydroxide, right? So CaOH2 is just calcium hydroxide. So nothing special when we name bases. Okay, go ahead and write this one down. So then we're going to look at, well, how do we start to like quantify these acids and bases, which how many hydrogen ions or how many OH ions are present. So we use pH to represent the concentration of hydrogen ions. Okay, something I want you to look at. Do you see how this hydrogen, it's inside these brackets? Okay. Whenever you see these brackets, and I'm just going to highlight it so you know what I'm talking about. Okay, those brackets, those mean the concentration. Okay, so write that down in your notes. So when you see brackets, not parentheses, okay, brackets are meaning the concentration. And so if we look at the pH scale, my picture stops at 1, but it goes to 0. Okay, so 0 is a really strong acid. Okay, so there's a very high concentration of hydrogen ions. 7 is neutral. Okay, so 7 means the concentration of hydrogen ions is equal to the concentration of hydroxide ions. And then 14 is a strong base, where you have very few to none hydrogen ions and a high concentration of hydroxide ions. Last, today we're going to look at, well, how do we just measure the pH? So when we're looking at different acids and bases, how do we know what the pH actually is? So we have 2 methods to measure the pH in here. The first one are indicators. I'll talk about indicators on the next couple slides, but they're just like chemicals you mix. And then the other one is indicator strips. Okay. So indicator strips, they are the ones in the picture on this slide. They are just little strips of paper. You dip it in your acid or base and it'll change colors, and they come with a key. So then like whatever color the strip changes is how you know the pH. The other options are indicators. So indicators are just different chemicals that you mix with your acid or base, and it's going to cause your solution to change colors depending on how acidic or how basic it is. Okay. So I don't know if you need to write this down. I'm going to change my slide. So there's all sorts of different types of indicators we use. Okay, so here's a generic table. Today we're going to use 3 of these. If you look off to the left, so this is the name of different indicators, and they show you the pH range in which these ones identify. Okay, so like today we're going to use bromothymol blue. Okay, bromothymol blue is really only useful if the chemical we're looking at has a pH somewhere between 6 and 7.6. Okay. And then if you look over here, it'll show you like how it changes colors. So if it's yellow, it's like closer to 6. If it's teal, it's about 7. And then if it's blue, it's like a 7.6. Okay. And there are better pictures out there on the internet that we will look at in just a little bit. Okay. We'll also use phenolphthalein today. So if you have a base, phenolphthalein is a better indicator. Okay, so it goes from 8.2 to 10. Again, and then there's a little key that shows you, depending on how the color changes, you match it up with the pH. Okay. Does that make sense? Okay. So lots of different indicators. If you take a look at the left, though, do you see how they all have like different ranges of pH values? Okay. So because of that, we have lots of different ones.